Okay, so standard 4 gives us a piece of paper that is 12 inches wide, folded at a 30-degree crease angle to make a crease, like that. So then, given the width, given this and this, we're supposed to determine the length of the crease right here. So we can do that first by finding out the angles of our piece of paper. So we're just going to draw hypothetical dotted lines to make it resemble a rectangle. Okay, just pretend that's straight. So we know the crease angle is 30, and so this is a right angle right here, and so this is going to act like one triangle, and so 90 minus 30 is obviously 60. And also we're given that because it's a piece of paper, like whenever you fold it, the crease is going to be the same as the folded part. So this is also 30, and so this is 90, and this is also 60. And so we know that so far that this is also a right angle, and that both of the 30s make up 60, and 90 minus 60 is also 30. And so this angle right here makes that 30, and that's another right angle. And also this must mean this is 60, because 30, 60, 90. And so we know that the width is 12. We can move this over right here. And with 30, 60, 90 rules, we know that the side opposite the 60-degree angle is 4 square root of is x squared of 3. And so if you divide 12 divided by square root of 3, we'll get 4 square root of 3. And the hypotenuse is 2 times the side opposite the angle 30, so that's 8 square root of 3. And so we can apply those rules again with this, which would make this right here 8, and that 16. So A equals 16 inches. And then B asks us that suppose that the side of the folding angle is theta degrees, so that means that we don't know what the angle size is going to be. So I'm just going to draw that same situation, but with the same paper. So let's just draw that, theta, theta, which must make this 90 minus 2 theta. Okay, and so it's asking us to use trigonometry to express the length of the crease as a function of theta, which just means make an equation out of it. So then it also wants us to check the formula using 30 again, just to verify this answer. Then we can start with f theta equals 12 cosine 90 minus 2 theta over cosine theta. 12 over cosine theta. Which, okay, we're given 12. The reason why it's 12 over cosine 90 minus 20 minus 2 theta is because we're searching for this length first, and then the reason why it's over cosine theta, it'll give us to the crease length. So then, yeah, if we're to plug in f30 equals 12 cosine 90 minus 2 30 over cosine 30, we're given f30 equals 16 again. And so for part C, it's asking us to find the value that makes the crease as short as it can be, which would just make us plug this equation is. And when you plug it in your calculator, plug the equation into the calculator and make a graph, it shows, if you go to the first quadrant at least, it shows something that looks like that. And so you find the minimum, and so the minimum turns out to be 35.3, comma 15.6, which means that with an angle of 35.3 degrees yields a crease length of 15.6 inches. And part C also asks us why the angles have to be smaller than 45. Okay, so referring back to this part, if let's say even the angle was just a 45, it'll make 90 minus 245, which just means that 2 times 45 is 90, 90 minus 90 is 0, and that would not work with the equation because that would just skew everything up. And also logically speaking, if we were to fold the paper more than 45 degrees, then that would just make the crease longer than the actual piece of paper, and then nothing from like the unfolded part would be exposed. So yeah.